Welcome to my channel, Arun Kumar at Exam Guru. This video is related to engineering mechanics, the most important subject in engineering. What is mechanics? Mechanics is a branch of science that studies the behavior of physical bodies when subjected to forces and displacements both at rest and in motion. In engineering mechanics, both kinematics and kinetics are crucial for understanding motion. What is kinematics? Kinematics studies the motion of objects by describing their position, velocity, and acceleration over time without considering any force involved. For example, when a pendulum is hung with the help of a string, and if you provide a small displacement to a pendulum, the pendulum moves and follows a path of simple harmonic motion. There is an initial displacement given to the pendulum. The motion of a pendulum is not due to the force but due to initial displacement provided. This is kinematics. Now what is kinetics? Kinetics considers the force and torques that cause or modify motion. For example, when a nail is hit by a hammer, the nail moves in downward direction due to the force that is applied on the nail. The mechanics is classified into mechanics of solids and mechanics of fluids. Mechanics of solids is further classified into mechanics of deformable bodies and mechanics of rigid bodies. The subject strength of materials or theory of structures is related only to the mechanics of deformable bodies, whereas engineering mechanics is related to mechanics of rigid bodies. Now, what is rigid body? Rigid body is a body in which the distance between all the particles remains constant. In other words, deformation is zero at all points regardless of applied forces. Deformable body is opposite to that of rigid body. Let's consider two examples. One is a rock, the other is a balloon. And if you take 2 points A and B on the rock and apply forces on all the directions in the rock, there will be no change in the distance between A and B. Now let's look at the balloon on the right. There are 2 points A and B marked on the balloon, and when force is applied on the balloon compresses and the distance between the point A and B reduces. That means rock is an example of a rigid body. That's why there is no change in the positions of points A and B, but in the case of balloon, it is a deformable body. What is force? It's not everyone. Force can be defined as anything that causes a change in the motion of an object. This change can be a change in the speed, a change in direction, or a change from rest to motion, or vice versa. Force is the action of one body on another body that tries to change the motion of another body. Force is represented by an arrow mark, with the arrowhead representing the head end of a force, and the end where there is no arrowhead is the tail end of a force. Now, in the Cartesian coordinates, if a force is applied in the positive x direction, the body moves along the positive x direction. Similarly, when the force is applied in the positive y direction, the body moves along that y direction. And similarly, when the force is applied in an inclined position, the body moves in the inclined direction. Now, what is characteristics of force? Force is a vector quantity. It is characterized by magnitude, direction, as shown in the figure on the right, where the magnitude is 5 Newton. And number 3 is point of application. That is the point where the head end of a force acts. The point of application is marked in the figure. And the line of action, the line which is extended beyond the head end of a force along the point of application. So the line of action is also marked in the figure. Now the forces are classified based on their line of actions as collinear, that is acting on the same line. You can see the 2 collinear forces. Number 2, concurrent forces, the forces which have the same point of intersection. And number 3, coplanar, that is forces which act on the same plane. Let's look at the practical example of collinear forces. In the case of a rocket propulsion, the rocket moves upward due to the force of the gases that is exerted downward. Both the forces are acting along the same line, so they are collinear forces. Let's look at the practical example of concurrent forces. The most common example is an hanging float, where the forces acting on the chains are examples of concurrent force. The collinear forces are classified into coplanar collinear forces and non-coplanar collinear force. Concurrent forces are also classified into coplanar concurrent forces and non-coplanar concurrent force. Coplanar collinear forces are the forces that are acting in the same plane. That is, you can see the collinear forces acting in xy plane. This is an example of non-coplanar collinear forces where the forces are inclined at suitable angle with xy plane. Now, in the case of coplanar concurrent force, there is a common point of intersection and the concurrent forces are acting along the same xy plane. And in the case of non-coplanar concurrent forces, forces are inclined at suitable angle with the xz plane. So these are some examples of non-coplanar concurrent force. What is moment? Moment is the tendency of a force to cause a body to rotate about a specific point or axis. Its magnitude is obtained by multiplying force with perpendicular distance. Its direction can be either clockwise or anti-clockwise. Let's consider an example where a rod is shown of length d and having a hinge at one end and a force F is applied in downward direction. In this manner, the anti-clockwise moment of magnitude force times distance, perpendicular distance, is produced. Now, if the force is acting in this manner, a clockwise moment of magnitude F into d is produced. Now, what is clockwise? It's a direction where the hands of a clock moves. So this one represents the clockwise direction, and the anti-clockwise direction is the direction opposite to that of clockwise. If we express moment in vector form, it is moment equals r cross F, where r is the position and F is the force. What is coupled? Couple is a pair of equal and opposite forces separated by a distance. If you look at the figure, the forces F are acting in opposite directions on two objects. They are separated by a distance d, and the body rotates, and because of which the couple took place, and the magnitude of couple is F into d, that is force multiplied by the distance separating them, and the direction in this case is anti-clockwise. Now, when the forces act in this manner, the magnitude of the couple is F into d, and the direction of couple is clockwise in this case. Now, what is principle of transmissibility of force? The external effect of a force on a rigid body remains unchanged if the force is transmitted along its line of action. That is principle of transmissibility of force. That is, if we draw a line of action for this force, the force can easily pass through the line of action, that is, transmissibility of the given force. Now, moment can be calculated based on principle of transmissibility of force. For example, a force F is acting on the object, and there is a point A on the other end of the object. The moment about the point A can be calculated by extending the line of action of the force F and multiplying with the perpendicular distance of the line of action from the point A. So we draw the line of action for this force, and the distance, perpendicular distance between the line of action and the point A is d. Then moment at the point A is F into d. What is resultant force? Resultant force is a single force that has the same effect as the combination of all forces acting on an object. It is a vector sum of all forces, meaning both the magnitude and direction of each force are considered. For example, if on a body a system of forces F1, F2, F3, and F4 act, and the body moves along the direction of the dotted line as shown in the figure, then the dotted line represents the direction of resultant force and the magnitude is capital F. Next, we will learn how we will calculate the capital F and its direction. So when collinear forces act on a body, it is easy to find the magnitude and direction of the resultant force. For example, when a stone is pulled by forces that is 30 Newton and 10 Newton in opposite direction, the net force is obtained by subtracting the force and act in the direction of larger force. In this case, the larger force is 30 Newton and the smaller force is 10 Newton. If you subtract, you get 20 Newton and it's act in the direction of larger force, that is 30 Newton. When two concurrent forces act at a suitable angle on a body, the resultant force is. In the figure, there are two forces F1 and F2 which are concurrent and are acting at an angle theta. Then the resultant force is F And the formula of F is root over F1 square plus F2 square plus 2F1 F2 cos theta. When theta equal to 0 degrees, the resultant force is maximum. That is, both the forces are acting in the same direction, so just add the two forces. Resultant force F equals F1 plus F2. And when theta equals 180 degrees, F1 and F2 act in opposite directions, and the resultant force F equals F1 minus F2. When more than two concurrent forces act at suitable angles on a body, the resultant force is obtained by resolving all the inclined forces in horizontal and vertical directions and taking sigma Fx and sigma Fy. For example, there are a system of forces acting on the body F1, F2, F3, and F4. They are all concurrent, meaning they have a common point of intersection. The resolved forces are obtained by taking cosine of the angle which the force makes with the corresponding axis. For example, F1 makes an angle theta 1 with the horizontal axis and F theta 2 with the vertical axis. Then the horizontal component is F1 cos theta 1 and the vertical component is F1 cos theta 2. If one of the axes makes an angle theta with the force F1, then the resolved force along that axis will be F1 cos theta, and that perpendicular to that axis will be F1 sin theta. For example, if a force F1 makes an angle theta with the horizontal axis, then the horizontal component will be F1 cos theta and the vertical component will be F1 sin theta. Similarly, if the force F1 makes an angle theta with the vertical axis, the vertical component will be F1 cos theta and the horizontal component will be F1 sin theta. If the force F acts in the first quadrant, and we are going to resolve the force in the first quadrant, and the force F makes an angle with the horizontal axis, then the resolved components are F cos theta and F sin theta, and both F cos theta and F sin theta are positive. When we resolve in the second quadrant, F cos theta will be negative, but F sin theta is positive. Similarly, when we resolve in the third quadrant, F cos theta will be negative, F sin theta will be negative, because both are pointing along the negative x and y directions. Resolving force in the fourth quadrant, F cos theta is positive and F sin theta is negative. In order to resolve the forces, we need to place the origin of coordinate system at the tail end of each inclined force and then find the components. So in the given figure, the forces F1, F4, and F3 are inclined, but F2 is horizontal and pointing in the positive x direction. So we need to resolve the forces of F1, F3, and F4. So for that, first let us resolve F1, and for that we need to place the origin of the coordinate system at the tail end of F1, and at the tail end the force F1 makes theta 1 with the horizontal axis, and the force F1 is in the first quadrant. That means the result components are F1 cos theta 1 and F1 sin theta 1. Now if you want to resolve the force F4, we place the origin of the coordinate system at the tail end of F4, and if F4 makes an angle theta 2 with the horizontal axis, the result components are F4 cos theta 2 and F4 sin theta 2. Similarly, if you want to resolve the force F3, the force F3 is in first quadrant and the result components are F3 cos theta 3 and F3 sin theta 3. Now we are going to find the sigma Fx, that is summation of all forces in the x direction. You can see from the figure there are four forces in the x direction, that is F2, F1 cos theta 1, F4 cos theta 2, and F3 cos theta 3, all pointing in the same direction. Hence, we add all the four forces. Now, similarly, we have to find sigma Fy by considering the forces in the y direction. In the y direction, F3 sin theta 3 and F1 sin theta 1 are pointing along the positive y direction. So both these forces are positive, and F4 sin theta 2 is pointing in the negative y direction, so that is negative. And the angle of the resultant force theta is tan inverse sigma Fy by sigma Fx. So this is how you manually calculate sigma Fx and sigma Fy. And the magnitude of the resultant force F equals square root of sigma Fx square plus sigma Fy square. Transfer of force from one point to another point in a body. There is a force at point A, and we want to transfer the force acting at point A to point B located at distance d away from point A. So in order to transfer the force, so we make sure that at point B there is no force acting. The net force at point B is 0. And we are applying the force of same magnitude at point A in equal and opposite direction. Now what do we observe? So we observe that the two pair of equal and opposite forces at a separated by a distance d will form a couple. The forces forms a couple with the distance d between them in clockwise direction, and that couple is marked here, which is force into d. When we transfer the force from one point to another point, there will be same force and couple of magnitude force times the distance between the points at that transferred point. Let's do 5 questions. Two equal and opposite forces not in the same line form. The right answer to the question 1 is option B, couple. Question 2. A 10 Newton force acts at a point and makes an angle of 45 degrees with the horizontal. The vertical component of the force is. So the right answer to this question will be option D. So if you draw the coordinate system and the force F acts at an angle 45 degree with respect to horizontal, the horizontal component will be F cos 45 and the vertical component will be F sin 45, and hence the right answer to the question will be option D, 10 sin 45. Question 3. The moment of a couple is. So the right answer to this question will be option B, equal to the product of one of the forces and the perpendicular distance between the forces. Question 4. A force vector F equals 4I plus 3J plus 5K Newton is applied at a point located at R equals 2I minus J plus K meters. The moment about the origin. We know that the moment M equals R cross F. We have to find the cross product. So how do we find the cross product? We put I minus J K, and the R vectors as 2 minus 1 1, and F vector is 4 3 5, and the value of moment equals I into, so we cross multiply, we get minus 5 minus 3 and minus J into, when you cross multiply you get 5 into 2, that is 10 minus 4, and plus K into, we get 3 into 2 6 plus 4. So the right answer will be minus 8I plus 6J plus 10K. And hence, the right answer will be option A. Question 5. Two forces of same magnitude F and F act at an angle of 120 degree, the magnitude of the resultant force. So when two forces are acting, then the formula of resultant force will be square root of F square plus F square plus 2 F into F cos theta. Here theta is 120 degrees. So we know that cos 120 degrees is minus 1 by 2. And if you substitute minus 1 by 2, we'll get the answer as F. The right answer, the question is option A. So don't forget to like, share and subscribe my channel.